5-4B. Point, slope, and slope intercept. Okay, so we're kind of not combining. We're doing both today, not at the same time. So first thing I want to do, we just did this. I'm recording, yes. We just did this going over the homework. So let's see how well you paid attention here. If we're going to graph this, okay, we're looking for the point.
Is it 3, 3?
It's not 3, 3.
It's negative 3.
It's negative 3, right? Opposite of what it looks like. And this is your x value. So opposite of that one.
I'm looking at the wrong one.
Opposite of this one would be a positive 3. Okay? So you get the point. Negative 3, 3. What do you do with that? You plot it. So the point negative 3, 3, right? This is an x value. This is a y value. This is your x-axis. This is your y-axis. Where do you move for the point negative 3, 3?
3 over left.
Left 3. 3 on your x-axis to the left. 3 up. Okay, so there's your point. What is your slope? Negative 2. If you wrote that as a fraction, what would it be?
Negative 2
over 1. Okay, so from that green point, we're going to go down 2, right 1. If you want to keep going to get a nice straight line, you can keep going. So your graph looks like that. Okay, with that in mind, you try the next one. Yes, CK. The warm-up. 5-4B.
Will we be graphing?
I don't remember. I'm not sure.
Are you doing the other one too?
Do the second one on your own. Very similar.
Yeah, we are.
All right, tell me what you got as the points. 2, right? So a positive 2 for the x value. A negative 2 for the y value because it's always opposite of what it looks like. So 2 negative 2 is your point. What's your slope?
1 over 2.
1 over 2. So if you plot 2 negative 2, that puts you here. Then a slope of 1/2 is up 1, right 2. Are you disagreeing with me, Shane?
Yeah.
Why? Oh, okay, here's the deal, Shane. X is left and right. Y is up and down,
Oh, I know, but like.
right?
It's not clicking.
No, but.
So positive
Oh.
2.
Oh. Well, why did they make the y and x like the wrong way?
What do you mean the wrong way? You're just, here's what I think is happening, okay? Here's what's probably happening, and this happens for a lot of people, so hear me in case this is happening for you too. A point, the x comes first, right? The slope, what comes first? The y. So just be careful with that. Slope is rise over run. So up and down first, and then left and right. But when you plot a point, it's x and then y. Left and right first, then up and down, okay? Be careful with that. All right. Not as of right now. I'm putting all your final exam stuff together right now. We'll talk about it soon.
Most of my finals are in the morning.
That's nice. Okay. So here's the first example. Okay. This is not long. There's just 4 problems to go through here. Okay. Listen. This first one says a line passes through 2 points. Write it in slope-intercept form. Okay. But I'm going to show it to you where we put it into point slope form first, because we've already done it where we put it into slope-intercept form right away. Okay. I'm going to show it to you this way because I actually like this way better. I think I might have shown it to you one time last week or 2 weeks ago. But here's what I need you to think about. If you have 2 points, What can you find from those 2 points? The slope, okay? Do you remember the slope formula? Y2 minus Y1, X2 minus X1. Okay, so label your points, and this is hugely important. If you mislabel, you're gonna misdo all of it, right? So make sure you are doing an X1, Y1, and an X2, Y2. Okay, it's not XX and YY. X1, Y1, X2, Y2. So if I plug that into the slope formula, it's going to be 3 plus or minus. Plus, in the end, it's 3 minus a negative 2, right? Which is 3 plus 2. Okay, so minus a negative becomes plus positive. Then it's x minus x, so 5 minus 4. So you end up with 3 plus 2 is 5. 5 minus 4 is 1. So my slope is 5, okay? 5 over 1, just call it 5, right? Anything over 1 is itself. Okay, so you have a slope of 5. Now it says put it into slope-intercept form, but I'm going to show you how to get there from point-slope form this time. So I've shown you this before, where you could plug this right into slope-intercept, right? Y equals mx plus b, and you plug in the y, and you plug in the m, and you plug in the x, and you solve for b. That's not the way I'm going to do it today. I want to show you a different way, and then you'll kind of have the ability to choose which way you like. Here's what I'm going to do for today. I'm going to start in point-slope form. Okay? If I put this into point-slope form, I need a point and I need a slope, and you get to choose which point you want to use. Which point would you like to use? 4, -2 or 5, 3?
5, 3.
5, 3. Good. I like that one too. Okay, so if we're going to use 5, 3 as our point, that's going to be our x1, y1. We're going to go y minus the y value. So y minus 3 equals the slope times x, is this going to be plus or minus? Minus the y, or the x value, which is 5. Okay, so you're here. This is your point-slope form. If it said put it into point-slope form, you're done. But it said put it into slope-intercept. And slope-intercept is y equals mx plus b. If you're trying to get to this form, really what you're trying to do is isolate your y. Get y by itself. Okay? How can I do that here? What would my first step be? We are going to add 3, but let's do something else first. Yeah, we're going to distribute this. Okay? So this is y minus 3 equals 5x minus 25. How do I turn that into slope-intercept? Add the 3. So I get y equals 5x minus 22, and that is your slope-intercept form. Okay, so we started in point-slope, and we just solved for y. Does that make sense?
Yeah.
Okay, let's.
Which one's right? The green or the orange?
The orange is the final answer because it's asking for slope-intercept form. But we just came at it from point-slope instead of plugging it straight into slope-intercept. Yes, find the slope, plug it into point-slope, solve for y. This would be your y-intercept. The negative 22. Yeah. Okay, we're gonna do it again. Okay, so this one says a line passes through these 2 points, put it into slope-intercept form. But again, I'm gonna start from point-slope form. What do you have to find first?
The slope.
The first thing you should do is find the slope. Okay, label this x1, y1, x2, y2. Okay, I want you to take 30 seconds and try to find the slope using those 2 points right now. Go.
Do we also like
Find the slope of that line.
Just slope?
Just the slope for now.
I thought I just picked.
No, slope is y2 minus y1 over x2 minus x1. Just like we did up here, right? You're doing this right now.
There's a Y on top.
Yes. Slope is always y on top.
My writing is really making me happy.
Good. All right, tell me what you got for the slope.
Wait.
Did you get 1/2? So it should be 3 minus 2
Yeah.
over 6 minus 4, right? So 1/2. Okay, so that's your m. We're going to take that and we're going to put it into point slope form, not slope intercept yet. We're going to do point slope. Which point would you like to use?
4, 3.
4, 2. Okay, so let's use this point. And a slope of 1/2. So now we're going to put it into point slope form. Okay, that's going to be y plus or minus?
Minus.
Minus what?
Wait, do we, what, oh, 2.
2, your y value. Y minus your y value equals, what comes next?
1, 2.
The 1/2, the slope. And then it's x plus or minus? Minus
4.
the 4. Okay. Third step is put it into slope intercept form. Okay. In other words, solve for y. Right? Get y by itself. It's just 3 steps. It's find the slope, put it into point slope, then turn it into slope intercept. Okay, so the first thing you want to do is distribute this, right? Y minus 2 equals 1/2 x minus what? 1/2 of 4, right? Distribute that 1/2. So minus 2. Now what? Plus 2. We're going to add this 2. So you get y equals 1/2 x. What does this become? 0. So you don't have to put anything there. You don't have to put plus 0. You can just call
So
it,
you just keep, how can you keep the half after you multiply? You just did it?
because you're doing 1/2 times x is 1/2 x.
Oh.
1/2 times 4 is 2,
Okay.
right? Sure, we'll do one more. Well, you know what? We're gonna do it again on these next 2. It's just with a chart instead of with 2 points, but it's the same process. Okay, so let's just do it here. We're gonna do it 2 more times, the exact same thing. Here it is. This says the table shows the altitude of a hot air balloon during its linear descent, meaning this is making a straight line when it descends, okay? What equation in slope-intercept form gives the balloon's altitude at any time? What does the slope and y-intercept represent? Okay, now here's what you need to think about. When you're given a chart like this, they told us it's a linear descent, so you don't actually have to check if this is linear, which means you can use any 2 points you want. I tend to use the smallest of the points, okay? So think of it like this. This is an x and a y. So this is the point 10, 640. Just like on the last one, we used the point 42, right? Same idea. Then another point, I would probably use 30, 590. Okay? In order to find the equation, the first thing we're going to do is we're going to find the slope. What should I label my 10 as? X1. So then what is 640? Y1. My 30 would be X2 and Y2. Okay, so if we're going to find the slope, Y2 minus Y1. So this is going to be 590 minus 640 over what?
30.
Oh.
minus 10.
30 minus 10, yes.
Why do you always have to do y2? Like, why can't you just do y1 minus y2?
You can. If you go y1 minus y2, then you have to go x1 minus x2.
Yeah.
So that's fine. You can do that. Yep. You just can't go y2 minus y1 and then x1 minus x2. You got to keep your 1s and 2s in the same spots. Okay, so if we simplify this, 590 minus 640 is a negative 50. 30 minus 10 is 20. That is not a beautiful set of numbers. That can be reduced. What would it reduce to? Divide by 10, negative 5 over 2. Okay, so that's your slope, negative 5 halves. We take that and some point, and we put them into point slope form. Which point do you want to use?
30 and 590.
30 and 590? Sure. You may use any one you want. Okay, we'll use that one. So point slope form then is going to be y plus or minus?
Minus.
Minus what number? The y value, the 590, equals our slope, negative 5 halves, and then it's x plus or minus?
Minus.
Minus and the 30, right? The x value. So far, so good? Okay, our next task then is now change this into slope-intercept form, which means solve for y. Get y by itself. What do you do first?
You distribute this.
Distribute, yes. Okay, so we're going to distribute this. So this is y minus 590. This is a negative 5 halves x. A negative 5 halves times a negative 30 is going to be a positive, right? And that would be 5 times 30 is 150, but 150 divided by 2. Or you can plug it into your calculator. Negative 5 halves times negative 30. You get what? 75. Okay, if you don't feel confident with the mental math, let your calculator do that work. What's your last step?
Add 590.
Add the 590. We want y by itself.
645.
So you get y equals negative 5 halves times x plus 665, right?
Yeah.
Sorry, I kind of crossed that out. Y equals negative 5 halves x plus 665. Okay, now the only thing that's different about this question is notice the question they asked. What do the slope and the y-intercept represent? So the y-intercept, this number, 665, is what?
The y?
It's the feet that you started. Is it feet? The meters, right? It's your y-intercept. It's where it hits 0. So it's where you're starting at 0 seconds. It's where you would have started your descent, right? That y-intercept is always like the initial number, the starting point, okay? So your y-intercept is the starting height of 665 meters. Okay. What is your slope? It's rise over run. It's y over x. What does it mean? It's y over x.
How much
Negative
out,
5
the more
2 meters
altitude
per
there
second.
is,
So
the more
you're
time.
dropping 5 meters every 2 seconds, right? That's what that's telling us here. That's the slope of the line. So this is dropping 5 meters, because it's negative, right? Every 2 seconds. So if you just label your y as meters, your x is seconds, it's negative 5 meters every 2 seconds. Or you're dropping 5 meters every 2 seconds. Does that make sense? Yeah? Okay, let's try one more and then we'll be done. All right. First thing you need to find here is a slope. Remember, this is your x and your y. So here's a point. Here's a point. Here's a point, right? We have all these points. You just need 2 to find your slope. So I'm going to use the first 2. Okay? To find my slope, I'm going to go y2 minus y1. So 4,570 minus what? 3,320. If it helps you to label them, you can totally rewrite this. Right? This would be your x1, y1, and your x2, y2. Okay, we put that over what? 3 minus 2. Y2 minus y1. Okay, so plug that into, I got a lot of junk up here. 4,570 minus 3,320 is 1,250 over 1. Okay, so you can just call that 1,250 for your slope. What's your next step? Step 1 is find the slope. Step 2 is put it into point slope form. Okay, so I'm going to use this because it's our smallest numbers. So point slope form would read how right now? Y minus your y value, 3,320, equals the slope times x minus what number? What's your x value at that point? 2. Okay? Okay, then once you're here, how do you solve for y? How do you put it into slope-intercept form? Distribute. So this is going to be y minus 3,320 equals 1,250x minus 2,500, right? 1,250 times 2. What's your last step? Right. So you're going to add this. And you get y equals 1,250x plus 820. Okay. What does the slope represent?
The water and time.
The slope is 12,050 gallons per what? What was our slope though? It wasn't 1250 over 2 this time. It was 1250 over 1, right? So it's 1250 per 1 hour. Okay, so 1,250 gallons per hour that the tank is gaining. Woo! Sorry, that was this part. No, we did. This, I did it right here. Slope intercept form.
Thank you.
You're welcome.